In this presentation, I'm going to give you a formal math definition, or something close to a formal math definition, for the items that are on your linear equations vocabulary sheet. What I'd like for you to do is to fill in the column titled Definition in Your Own Words. This is where you put the definition in words that are useful and helpful to you, and to fill in the example or drawing to help you remember. On some of these, I give you examples. In some of them, you'll have to come up with the examples on your own. So the first is solution. A solution is a number or a pair of numbers that make an equation balanced. That is, they make the two sides equal when plugged in for a variable. In an equation with a single variable, for example, in this case, the equation is x plus 2 equals 5. X equals 3 is the solution, because when I plug 3 in for x, it makes the two sides of this equation balance. In an equation with two variables, in this case 4x plus 3y equals 24, 3, 4 is a solution, because when I plug in 3 for x and 4 for y, I get an equation where the stuff on the left-hand side, which comes out to 12 plus 12, balances or equals the stuff on the right-hand side, which is 24. The next term is linear equation. A linear equation is an equation whose solutions form a straight line when they're graphed. So for example, if I took all of the xy pairs that are solutions to this equation, that make this equation balance, and I graph them all and then connect them, they would form a straight line. Next is slope. Slope is formally defined as the ratio of the change in the... Oops, I have this backwards. It is the change in the y to the change in the x. It is the rise over the run. And rise is the change in y, run is the change in x. The x-intercept is simply the point where a line, or it could be a curve, crosses the x-axis. So for example, the x-intercept of this green line is that point right there where it crosses the x-axis. The y-intercept is the point where the graph of an equation crosses the y-axis. In this case, I've illustrated it with an example of a graph that is nonlinear. This is the graph of a quadratic function. And even though it's not a line, it has a y-intercept. It has a point where it crosses the y-axis. Notice this graph actually has two x-intercepts, here and here. Next is slope-intercept form. This is a form of the equation of a line where the coefficient, that is the number in front of the x, is the slope, and the constant, the number that we're adding or subtracting, is the y-intercept. Typically we write slope-intercept form as y equals mx plus b. Standard form is a different way of writing the equation of the line. For our purposes, it's enough to know that in standard form, the x and the y variables are both on the same side of the equal sign. And typically, we write an equation in standard form as ax plus by equals c, where a, b, and c are simply numbers. So for example, an equation written in standard form might look like this: 3x plus 2y equals 12. In this case, a is 3, b is 2, and c is 12. The a, b, and c in standard form don't stand for anything. They're not the slope, they're not the y-intercept, they aren't anything useful, they're just numbers. Next is domain. The domain is the list of all values that go into a function. Typically, these are the x-coordinates when we graph the points on a function. Next is the range. The range is the values that can come out of a function. Remember when we learned about O reliable? The range is the numbers that she spits out, the numbers that can come out of that function. Typically, these are shown as the y-coordinates. Zero slope. A line has zero slope when we calculate the slope using rise over run, and the answer we get is 0. So an example of a line with zero slope is this line here. As I move from one point to the next, the rise, how much I go up or down, is 0. The run is whatever it is, but 0 divided by anything is still 0. I can identify a 0 slope if I look at a table of values. So here's the table of values, and notice that the rise, as I go from 4 to 4, the change is none at all, 0. The run in this table, as I go from 2 to 3, is 1. So rise over run is 0 over 1. 0 divided by 1 is 0. Next, we have an undefined slope. An undefined slope is a line where the slope calculation yields a denominator that's 0. And a fraction with a denominator of 0 is undefined. So here's an example. This straight up and down line has a slope of 0. If we were to look at it in a table, here are some points that you might find along this green line. As I go from 3 to 4, that's moving up by 1. My rise is 1. As I go from 2 to 2, my run is 0. I'm not changing at all. When I plug these numbers in to the rise over run formula for slope, I end up with 1 over 0. Dividing by 0 is undefined in math. If you have a hard time remembering the difference between 0 slope and undefined slope, go ahead and do the slope calculation and then enter this problem in your calculator. This is 1 divided by 0. When the slope is undefined, your calculator is going to give you a message that says error because dividing by 0 is undefined. When the slope is 0, when you have 0 divided by 1, your calculator is going to simply return 0, which is the correct value for the slope. Next, we have the definition of a positive slope. A positive slope is the slope of a line or a function where y goes up, y increases, as x increases. So for example, this line here has a slope of positive 1. As y goes up, x goes up. As we do rise and run calculations, we see as y goes up, the rise is positive 2, x also goes up, the run is positive 1. A positive divided by a positive gives us a positive slope. Last, we have a negative slope. A negative slope is a function where y decreases, y goes down, as x increases, as x goes up. So if I were to trace from one point to the next on this green line, as x goes up, as I move right, y goes down, I move down. So to get from one point on this line to another, my x-coordinate increases, but my y-coordinate decreases. This line shown here has a slope of negative 1. When we have points given in a table, so these are some points that might go with a different line, as I go from 10 to 8, I'm going down by 2. So in this case, my rise is negative 2. That's my y value is decreasing. My run is positive 1. My x value is increasing. So as x goes up, y goes down. When I place rise over run, I have negative 2 over positive 1. A negative divided by a positive gives me a negative. So when I do the slope calculation for a line that has a negative slope, my answer is negative.